Today's lecture is going to be about cloud computing and cloud native development, which is one of the hot topics nowadays in software development society. I'm going to talk about this technology and the important thing about cloud computing, why we should migrate to cloud, and when we migrate to cloud, what things we should consider. So, yeah, my name is Moeid Heidari. My supervisor for PhD course is Alexey Paznikov, Professor Alexey Paznikov. I'm a PhD candidate in cloud computing and cloud native tools optimization and any kind of cloud native developments. So my current position is DevOps and cloud engineer at Bosch, Sweden branch. And yeah. So the agenda for today's lecture is going to be about an introduction about cloud computing and the different types of service models. Then we will dive deep into the hypervisors and the visualization technologies under the need of cloud computing technologies, and we will talk about different techniques of hypervisor and visualization and how to separate the resources of a server. And then we will jump to the cloud computing platforms and compare different cloud computing platforms. Specifically, we will be talking about OpenStack as one of the chosen cloud computing platforms, and we describe the components that that OpenStack provides. And then we analyze the characteristics of a cloud provider, a public or a private cloud provider. Then we will talk about distribution in cloud computing and different techniques of distribution and synchronization of data and computing. Then we will jump to the networking in cloud, and we introduce some important topics in networking in cloud. So, yeah, the first thing, let's introduce cloud, and let's see what is really cloud computing and why we need to have cloud as our computing source. So based on the definition, cloud computing is a kind of technology that can help us to access to the shared pools of configurable computing resources. So it means every time when we delegate our computing and our data processing to a remote server or to a server that has a shared pool of resources, then it will be a cloud computing. So we will deploy our softwares on a remote server, which is able to scale, and we will have the elasticity on this server. Then we don't need to be worried about the underlying technologies and the hardware resources, software resources. Everything will be managed by the team or the company that is providing these cloud services. So yeah, it's actually a cloud computing system. But when we talk about cloud computing, it doesn't matter if you are working in a large-scale company and you have your own cloud computing platform inside that company, or you have a account or a profile in a cloud public cloud provider. So anyway, some kind of characteristics of this cloud infrastructure. But rather than that, we have different types of cloud systems. First of all, we have a public cloud provider, which is going to be offered by a third-party provider. Like, as you know, we have different public cloud providers like AWS, like Google Cloud, Microsoft Azure, or DigitalOcean or Alibaba Cloud. Even in Russia, we have a Yandex Cloud, and different companies are providing cloud as a computing infrastructure. So the main property of this public cloud is the availability for everyone. So it means that it's available to anyone over the public internet. So you as a single person or as a team or as a company, you can collaborate with this public cloud provider and deploy whatever you want on their own servers, and then everything will be managed by the provider company. And yeah, it can scale quickly because they have a large amount of computing resources. So you don't need to be worried about the computing resources anyway, because it's going to be offered by them. Of course, most of the times it will be based on a model like pay as you go, or pay as you use. So the only thing that you need to care about is just the price and the optimization of these expenses inside these cloud infrastructures. Rather than that, you are not going to be worried about anything else. So beside this public cloud provider, when you are working in a large scale company, most of the times you will have a private cloud system which is being developed or maintained by a team internally in that organization. And these private cloud provider is going to provide the services not just not to public people who have access to public internet, but it will be just accessible for the employees of that company. So it offered to selected users over the internet, or provide a private internal network. So as an example, here in Bosch, we have a private cloud system which is being provided by a very big team called BD, which is responsible completely for this cloud infrastructure. And whenever we want to have a computing resource or something like that, we just use the resources from this private cloud system, and it's just accessible for the internal employees. The advantage of this private cloud provider is that it provides a greater security control, because it works just inside the local network of the company, and it's not going to be accessed by other people or being attacked by the attackers or anything like that, because you need to be a part of that network whenever you want to use this cloud infrastructure. And one of the trade-offs of that is we need to have traditional data center staffing, because the whole of the data center is being controlled by the same team which is providing this cloud infrastructure, and it's not that much large scale like a public cloud provider, and the companies are always worried about the amount of resources and the computation systems, because when they want to scale this system, the elasticity degree of this system is not that much high as we have in public cloud providers, and you need to add more nodes, more computing units, and you need to take care of the whole data center in terms of physical damage or cooling system, networking infrastructure, and all of those things. But rather than that, beside public cloud system and private cloud system, sometimes we have a hybrid cloud infrastructure that the team that I was talking about, BD from Bosch, recently they migrated from private cloud to the hybrid cloud. It means it's a kind of combination of both public and private cloud, and most of the times they provide this cloud infrastructure system as a B2B service to other companies which they have contract with, or something like that. So it's not still open for public people having access to public internet, but they will be provided to some other companies out of the company. But it will be based on some contract processes and all of those that they need to be a part of the company's network to have this service. But again, the trade-off of that is it has a shared security responsibility. Still is not much worse than public cloud providing, because still we don't have free access to this system, but the companies which have access to this system are chosen by us, and we have a contract and we know them. So security is a little bit lower than private cloud, but still is not equal to the public cloud provider. Yeah, so maintaining of the sensitive data in this hybrid cloud is also hard because you are not going to maintain and take care of the data that are just belong to your own company, but you are responsible for the whole data and processes of other companies which have access to this system. So these three cloud providers are the cloud providers methods or paradigms that are available nowadays. And yep. So beside the types of cloud providing and the methodologies that people use to provide these kind of services, we have different levels of the certain cloud services. So in different levels, we categorize them. When we provide a system just as a hardware resource to the end user, and we say, hey, this is your hardware, and we don't manage anything for you. The only thing that we provide you is just the hardware, and you are responsible for the whole system. Like a team which is responsible to create a data center for you and to prepare this data center for you. And after having this service, this physical infrastructure service, then you are responsible for data center, and you need to take care of it for the whole time that you want to have it. Then you are responsible for the networks infrastructure, for the storage, physical services, even the whole virtualization and operating systems. All of the applications that are over this infrastructure are being controlled by you. So no one is responsible for that. If something happens, if a disaster happens or anything, you are the only one who is responsible for the system. And we call this system on-premises infrastructure. So this on-premises infrastructure is the lowest level of cloud providing, which is not considered most of the time, at least today, when we have these type of cloud providers, then almost no one is thinking about that, rather than the companies which want to have their own cloud infrastructure. And after that, we have different type of services. We have infrastructure as service, which is actually about the service when you just provide the infrastructure. I mean the whole software, the whole hardware infrastructure, and also the networking part. You take care of the data centers and all of those things. But the visualization of that, the physics and the visualization, operating system, database, and everything. Sorry, the operation system, not the visualization, because visualization comes when you get a service as a hosting service. So yes, actually, or infrastructure as a code. If I want to bring an example, will be EC2 from AWS, which is a service for computing. It provides you just the virtual machines ready to deploy softwares on, and it has the whole visualization infrastructure underneath, and you don't need to be worried about the underlying technologies for this visualization. So the VM, actually EC2 provides you VM, and you can control that VM from the time when you take it from the service provider. Or Microsoft Azure Visual is actually an identical service of AWS EC2, or Microsoft Azure Virtual Machines, and Google Compute Engine also is something like that. Rather than that, we in the next level we have platform as a service, which is a service that has all the things that you want as a service prepared. For example, if you want to have your visualization ready, the operating system should be ready on that before delivering to you. And the whole databases, for example, if you want a database, or if you want to have some dependencies already installed on that, or you want to have some softwares or some specific kind of configuration should be already on this system. And then we call it as a PaaS, or platform as a service, because you will receive not just an infrastructure as a service, but you but you receive a platform as a service, which is ready completely. As an example, if you want to have a virtual machine that has the whole dependencies to run a Node.js application or a .NET Core application, then the whole databases installation, the whole libraries installation, and all of those configurations will be ready for you on this system, and after that it will be delivered by the provider service to you. So Google App Engine or AWS Elastic Beanstalk or Microsoft Azure App Service or Heroku, these are the kind of platform as a service providers. So AWS Elastic Beanstalk actually is a service where you can deploy your services as simple as possible. You are not going to be worried about the operating system. You don't need to be worried about databases or any other kind of services. Just the source code that you have will be enough to bring up the application with the Beanstalk service being provided by AWS. So the only thing that you need to be worried about, and you are the responsible person for that, is the application and the data which is being available for the application. The data that is going to be fed by the application is your responsibility. So it's the next level of the infrastructure as a service. And after that, one of the most commonly used service types is software as a service, or shortly we call it SaaS. These software as a service, actually, these are the services that will be deployed for the end users. So user don't need to take care of any infrastructure and the software related thing of this service. As an example, Google Workspace is a software as a service, or Google Gmail, or Microsoft 365, or Salesforce, Dropbox, Slack, even this Google Meet that we have the meeting on, or the Discord messaging system. All of them are just a software. The end user is just providing data, and that's the only thing that you need to care about. Rather than that, we have some new kind of services, which is function as a service, that is completely related to the serverless computing, where you don't need to worry about your infrastructure and the software related thing. Even you don't need to deploy these dependencies or the services that are being required by these functions. So one of the most commonly used and well-known serverless computing system is AWS Lambda, which is a service where you can just provide your function. You can just provide this source code as a function. I don't know, it can be a Python function, or it can be a function from any language. You just upload this function that you want, and then an endpoint will be generated for this function. Then your users can just send the required data and get the result. So the function will be executed on the fly without any concern about the infrastructure of that. So Azure Functions also is doing the same thing as AWS Lambda, and Google Cloud Functions also is doing the same thing. Rather than that, we have CaaS, or container as a service also. So container as a service is a service that is being used to manage or orchestrate the containers that you want to deploy. It can be a Docker container or any kind of containers that you want. But as an orchestration engine, most of the times cloud providers are providing container orchestration as a Kubernetes engine. For example, for Google, it will be GKE, or Google Kubernetes engine. For Azure is AKS, or Azure Kubernetes Service. Or in Amazon, we have two different types of these container as a services. So Amazon ECS is Elastic Container Service, which is a system that can control and manage your containers, but at the same time it provides another service, which is a Kubernetes service, and we call it EKS, or Elastic Kubernetes Service. So yeah, it's about different types of services which are being provided by cloud. So if we go deeper a little bit, we get to the hypervisors and visualization. In a cloud computing world, it's very, very important to have as much as deep knowledge of these hypervisors and visualizations, because it's going to be rather important if you want to have your own cloud infrastructure system. Then it's required to have at least the knowledge of hypervisors and understand how this cloud providing system actually is creating these hypervisors, and what is the difference between visualization and containers. So where is the hypervisor actually located? Do we need to manage our OS, or the hypervisor should be upper than OS, or we can use hypervisor directly connected to the hardware and not using any operating system? So regarding this topic, we have two types of hypervisors, which is the type 1 bare metal hypervisors. This kind of hypervisor is connected directly to the hardware and acts as entry points of our infrastructure, and we don't need to have an operating system other than that. So this hypervisor actually is going to be like VMware ESXi or Microsoft Hyper-V or any kind of other technologies. And after that, the guest OS or operating system is going to be deployed over these hypervisor, these directly connected hypervisor to the hardware. Then we have the second type, which is the type 2 hosted hypervisors, and these hosted hypervisor actually is located in a higher level up in the operating system. And as an example, VMware Workstation or Oracle VirtualBox is going to be an example of these kind of hypervisors. So yeah, here you can see more examples of these hypervisors, like KVM, for example, as a kernel-based virtual machine in Linux. Is going to work as a bare metal hypervisor for us, and then after that, combining it with something like QEMU is going to be a perfect solution for visualization in Linux machines. The second type, as I said, VMware Workstation Fusion or Oracle VirtualBox Parallels Desktop are going to be relevant examples of these kind of hypervisors. And the hypervisors that AWS is using in the underlying infrastructure, actually they try to so in the beginning they were using Zen as the hypervisor infrastructure, but after that they tried to create their own hypervisor system, and the whole cloud computing platform underneath cloud computing platform is being developed by the AWS team. So now they have Nitro, which is this AWS developed system, and it's a kind of combination of the dedication hardware and lightweight hypervisors. Actually, it's KVM based. It means it's using the Linux kernel for the hypervisoring, and yeah, so it has a direct connection with the hardware, and it creates the virtual machines right up in the hardware infrastructure. And yeah, so AWS is using this Nitro hypervisor for the instance types like C5 and M5 instances in ECU service that they provide. So whenever you want to create the ECU system, you can choose if you want to have C5 instance or M5 instance or any other kind of instances. So yeah, so continuing on hypervisors and visualizations, we have something called QEMU or Quick Emulator, which is the open source machine emulator and visualizer. So it most of the times it works actually over the KVM. So the job of the QEMU is just visualization of different services like disks, like networking, like graphic cards, or any other kind of things. But still, the main responsibility of this virtualization is on KVM system. So QEMU sometimes can work in combination with KVM, and sometimes they can work without KVM even. But the trade-off of using QEMU without KVM is that QEMU will be responsible for the architectural translations of the binary execution things. So whenever you want to actually run your binary executable files, if the hardware, the chosen hardware for the visualization is different from what you have in the kernel, then QEMU is responsible for the translation of that, which is a time-consuming operation, and is going to lower the performance of the whole system. Yeah, so it actually doesn't need to have the visualization extension. As I said, it can work on its own. So in this picture, as you can see, we have the physical hardware in the lowest level, and then we have the Linux host kernel. Inside the Linux host kernel, we have the KVM subsystem, which is responsible for that. So whenever you install a Linux kernel system, then by default you would have this KVM. If you in a condition where you have the visualization enabled on your processor, then this KVM can create visualization for you. Later in some slides ahead, we will talk about these tests also, and we will show how to check if your processor is going to support it or not. Rather than that, over the KVM subsystem, as I said, we have the QEMU libraries, and then beside that we have a system called libvirt, which is a very important system. It's a kind of library that you can use as an API between the user and the QEMU libraries, or it can directly work with the KVM. So it provides some APIs, like how you work with network APIs of your operating system, or graphic APIs of your operating system. So libvirt provides you such possibility to talk to these hypervisor systems. So there are lots of different libraries being provided for different programming languages, from libvirt for Golang, for Python, for C++. It means that in these programming languages, you can use this library, and easily you can create virtual machines with this libvirt. So you just provide the XML DOM and the specification of the virtual machine, then you will have access to all the functionalities of this libvirt. Then whenever you run the code, then you can create your virtual machine. So being this said, if you have this functionality being provided as a HTTP API or something like that, then easily you can say that you have a very simple version of cloud providers. So you can provide these APIs to the end user, then the end user will call these APIs and can create virtual machines on your server. So the whole idea of a cloud provider, which is providing infrastructure or computing units as a server, is just like that. So there might be some other libraries in this level also, but most important of them are just libvirt and QEMU libraries. And then we have the processes. We can have different processes being initiated to work with this system. Libvirt utilities, libvirt daemons as Linux service, background service, which is working all the time to make this communication available between your host machine and the virtual machines. And one of the most important things that being controlled by this system is the networking stuff of your virtual machine, because you cannot have network disconnected from your virtual machine to the host machine, because most of the times you are going to make a connection between these two networks and transfer packets between these two, or you want to do a load balancing or internet access or any other kind of things. Then you can run different QEMU processes. It means different virtual machines on a host system, as long as you meet you don't meet the limitation of the hardware infrastructure. You can create any number of virtual machines as you want. So by being this said, virtual machines can be in different architecture, different operating system. Yeah, like it can be a Windows virtual machine being running on a Linux system or vice versa. So Windows gets kernel as a dedicated kernel for this virtual machine will be deployed completely with this virtual machine. So it's an introduction to the difference of the virtual machine to the containers, where in the containers you don't have actually these kernel, a copy version of this kernel being deployed by the container, because containers are using the shared kernel of the host operating system. That's why they are very lightweight and they can be created and built easily. But with the virtual machine, we will have the kernel with the virtual machine. That's why we can have different type of architectures. Yeah, we can have virtual machine with Fedora, with I don't know, or any kind of virtual machines and the underlying architectures. So QEMU with KVM provides the low-level virtualization. QEMU handles the emulation of peripherals like disk, network, and graphic devices. As you can see here, this setup provides a balance of good performance thanks to KVM's hardware acceleration. But as I said, it's just available in a condition where you have these hardware acceleration enabled on your processor, and the flexibility due to the QEMU broad device support. Sorry. How to know if your system supports kernel-based virtualization? That's a very good information. Very, very good question. Whenever you want to create virtual machine on your system, the first thing you need to check is that you need to check the CPU virtualization support, run the command. If you run the command lscpu, or if you take a look at the file located in the pros CPU info and look for VMX for Intel processors or SVM for AMD processors, you can see all of those information that you want. You can check if KVM modules are loaded, because if your operating system doesn't support a hardware acceleration, then these KVM modules are not going to be loaded. Then ensure virtual machine is enabled in BIOS or UEFI, because even if your CPU supports virtualization, it still must be enabled in the BIOS or UEFI settings. Mostly when you see that you don't have the acceleration or visualization enabled, the next thing that you can check is if it's really enabled in the BIOS system or not. Maybe your hardware is supporting that, but it's not just enabled in the BIOS system. And similarly, if you run ls mode and look for the KVM word, then you can see that we have different information here. The first one shows actually if it supports the visualization or not. And then you can see if the modules are loaded or not. Then IRQ by PaaS, actually it's the interrupt request bypass. This is a very cool feature where when you want to have a virtual machine enabled, and when you run your virtual machine, actually this virtual machine tries to get the interrupt requests from the user and bypass it to the underlying hardware system or to the process. So somehow we need to get these interrupt requests and bypass it to the actual hardware. Or so basically that it will be transferred or bypassed to the host machine, and the host machine then will transfer it to the processor. And in this way, actually, you can feel that you are really working with this virtual machine on your system. Until here, if there is any question or something like that, we can talk about. If not, I'm going to jump to another topic, which is cloud computing platform. Any question, any concerns? Okay, so seems to be nothing here. So cloud computing platform is a kind of platform where you have a bunch of functionalities that you want to configure and maintain a whole cloud computing system. It's not just about the just the computing infrastructure. It's about actually everything of a cloud computing system, like computing units like network configuration, network topologies, security things, or even it can be about the containers, it can be about the orchestration, it can be about messaging system, or IP management or IPAMs. It can be about everything. So of course it needs to have different modules, like a web UI panel, like a authentication provider system, or the message broker that can stand in between different microservices of these cloud computing platforms. So there are lots of things, or the actually the disk provisioner, which is one of the most important things in cloud computing, because when you deploy something and when you create a virtual machine or something like that, you need to have a disk, you need to have a storage system. So mostly this storage system is being provided as a remote storage system, and automatically provisioned storage system, where you can just request for the storage that you want, and the system is responsible to make this storage system as fast as possible, as elastic as possible for you. So yeah, we need to have such a system in a cloud computing platform. So by saying that, we can list some examples of these cloud computing systems. Personally, I prefer OpenStack to all of other cloud computing platforms because I have experience with that. It's a genius and really amazing stack for creating a cloud computing system. It's fully open source. So as you can see here, it's an architecture, a very general view of the architecture of OpenStack. In the next slide, we will go through some of the components of OpenStack. So for this picture, it's not important if it's not that much visible, because in the next slide we will talk about different components of that. So in addition to OpenStack, we have CloudStack. Also, we have some other types of cloud computing, like Apache Mesos, or OpenNovella, or VMware vRealize Suite. These are also the cloud computing platforms, but specifically in this lecture, we are going to talk about OpenStack. Okay. In the previous architecture, you see that we have a service called Nova. Nova is one of the components of OpenStack, which is responsible fully for the virtual machine. So it's a system that can work directly with the underlying hypervisor. And the perfect thing with that is the flexibility of this service, because it doesn't matter what kind of hypervisors you want to have. OpenStack is not going to restrict you to use any specific type of hypervisor. Actually, you can use any type of hypervisor and you can just configure it with that. And then your Nova service will be deployed and will be available to handle the virtual machines and the computing tasks. All of the visualization thing will be with Nova. From creating the virtual machine, creating the images, creating the flavors, and provisioning these virtual machines, and everything will be a responsibility of this Nova. So Nova is an API system, is an HTTP API system that has its own scheduler, its own console, certificate management, and the console auth or any kind of other services, and it has its own message broker here. So every component of OpenStack is being deployed like that. It has its own number of microservices, and then between these microservices we have a message broker. So it's not a very centralized system. It's completely modular based. So you can use the services that you want. You don't necessarily need to deploy everything because it's a very big system. And yeah, Nova is a compute service, and then we have Swift, which is an object storage service, works as a S3 bucket storage system, like what we have called S3 for Amazon. Here you can use Swift to have this S3 bucket system. So you don't need to deploy any other services like Minayo, for example, to support this S3 object storage system. So object storage service will be being provided by Swift. I don't know if in this architecture we have Swift or not yet. We have Swift here, Swift object server. So we have a proxy server for Swift, then we have account servers, different account servers, because we need to provide account servers to other modules to be able to create accounts and manage the objects on these object servers, and the container server also, of course, is a part of Swift as an object storage service. Then we have Cinder as a block storage system. So I'm not going to talk about all of the components here because it would be very time consuming, but just the most important ones. Neutron, personally, I believe that after that, Nova Neutron is the most important component of OpenStack because it's responsible fully for networking stuff, networking configurations, creating different subnets and routers and load balancers, floating IPs, releasing IPs, DHCP servers, and configuring public IP servers or using IP pool. Everything will be managed by networking service, which is Neutron. And Neutron have a full communication with the Nova as a compute service because it needs to provide the networking to the computing system. And Keystone is undeniable service of OpenStack because it's an identity provider service. Actually, without having Keystone, you cannot have OpenStack because it provides the full authorization and authentication support for OpenStack. So it manages all of the role-based authentications, all of the authorizations, user management stuff, and all of those things. So Keystone actually it's an undeniable service from OpenStack. Glance is a service. So services of OpenStack are much more than what we can see here. But yeah, there are some services where you need to have at least the simplest possible OpenStack working services. So like Glance, for example, is not one of the major things because even without Glance, you can still work. That is responsible for managing the dish and server images. But for example, Horizon is a web-based user interface for OpenStack service. Even if you don't have Horizon, still you will have the CLI application for OpenStack. You can work in the console, so it's not that much crucial for having OpenStack up and running. But Heat also is available, heat is not that much important because you will need it whenever you want to have the orchestration service. So if you deploy heat, then you don't need to use any other orchestration services like Kubernetes or Docker Swarm or OpenShift or any other things. You will be able to handle the orchestration of different containers just with heat service, which allows the developer to store the requirements of a cloud application in a file. So as you work in Kubernetes with YAML files, for example, the heat has its own configuration and the file structure. Telemetry is a telemetry service, actually, which is not very important. It's just important when you want to activate the billing service of your OpenStack, whenever you want to deploy a cloud computing system to end users and you want to have the billing service. This telemetry service is responsible to compute the whole billing and the cost management, and all of those things will be responsibility of this telemetry. Or we have Trove as a database service. You can use Trove, for example, whenever you want. Let's go back to this slide. Whenever you want to provide a SaaS system or software as a system, software as a service, then you want to deploy a database, for example. As an example, so in Yandex Cloud, for example, you can see that they have different type of databases as a service. It means that you just whenever you have an account on this system, then you can just deploy or request for a database service, and your database will be ready. The only thing that you will have is just the link and the credentials to the database, and then you don't need to manage anything of this database service. So if you use Trove, then you can provide database as a service to your end users. So it can be for a relational or non-relational database even. Or Sahara is a data processing service. Again, it's a service where you can provide as a software as a service or a SaaS. Then Zakar is a messaging service. Again, it will be possible to provide it as a message broker system, as a messaging system. And Barbican is the key manager. It works like, if I want to bring an example, it will be something like Vault being developed by HashiCorp, which is a service where you can put and manage all of your key stuff. So in Amazon also we have such services. In Google Cloud also we have. So using Barbican, you can provide key as a secret data management system. Or Magnum is a container orchestration engine, exactly like Kubernetes. Designate is a DNS service. You can have your own DNS service in your cloud environment. Then you can provide DNS query results to your end users, or you can have this DNS service locally working in your local network or any other thing. Manila is a shared file system that can work like NFS or CIFS for a cloud system. And Octavia is a load balancer system that provides the whole load balancing services. Actually, when you deploy OpenStack, if you don't have Octavia, then you won't have any load balancing possibility there. Yeah, because OpenStack is a very large topic. If there is any topic or any question about OpenStack, please let me know. Okay, then I will continue. So the next topic, which is one of the major things when we are talking about cloud provider systems, and it doesn't matter if it's a public cloud provider, if it's a private or hybrid one, or even community cloud provider, but we have some concerns when we provide such service. The first thing is the scalability. Scalability is the ability of this cloud infrastructure to scale itself, to scale the resources up and down when it's required, when it's needed. On-demand scalability is one of the most important things of a cloud provider infrastructure. And the major thing about the scalability is the speed also. We require the infrastructure to be scaled quickly on demand, because we don't want our users um, to feel any server downtime or problem with the services. We want the services to be scaled up whenever the number of requests to the server is growing, when the computing processes would take longer time, and servers with the current amount of replications is not possible, is not able to provide the answers to the requests. Then in this case we need to have the scalability. Most of the public cloud provider systems have an underneath infrastructure for this scalability and is fully automated. It means whenever the scalability will be required, automatically the cloud infrastructure should be able to scale the resources without any manual operation or any other concerns. So this is about scalability, which is one of the topics that in the following slides we will talk about. And the elasticity is the degree of the scalability. So how much a service is elastic, which is about automatically adjusting to the changing demand without user intervention. So that is why in most of the cloud providers like AWS, we see the elastic word at the beginning of the service names, like EC2, for example, Elastic Computing Unit, or ECS, or Elastic Container Service. So everything, as they claim in AWS, they claim that all of the services that they provide a high degree of elasticity. It means that they are elastic. On-demand self-services are the services where you can demand them automatically, and you can have them without sending a request for a manual operation or something like that. So the user is able to manage all of these services. So yeah, just. Okay, so on-demand self-services, users can provision resources and services without human interaction from the provider. It's mostly about the service, about the softwares as a service, as we talked before. So when we want to have a database, we just simply click on a button, provide our specification, and then we have the database up and running. Or it's true about all of other services, like secret management system, like messaging system, or DNS systems, or network stop systems. So services should be self-service and should be on-demand self-services. Broad network access is another thing which is very important. So services should be available over the network that the user aims to be inside. So aims to be a part of that over the network, and accessible through standard mechanism and devices. And this broad network access is not just about providing this network, but about the controlling and management of the security of this service and the accesses. Then we have resource pooling as the last topic that we want to really talk about and mention in this lecture, because the resource pooling is a pool of the resources, and it should be always enough for a multi-tenant model, for a cloud system that is going to be deploy services for multi-tenant. So it's a kind of multi-tenancy support of the cloud provider systems. So resource pooling should be always have enough resources for scalability. And then most of the cloud providers have pay-per-use. It means if you, for example, take a service like EC2 Amazon, you don't need to pay monthly, because in this way it doesn't matter if you use this service or if you don't use this service, because this service will be dedicated and reserved fully for you. So in this case, actually, if the user is not using this virtual machine, or if it's not using enough of this virtual machine, then you actually you actually are just losing the resources. You are just wasting the resources. So that's why in such cloud providers, you pay as you use, and it's mostly hourly basis. It means if for 1 day or 2 days or 1 week, for example, you are not using these virtual machines, or not just virtual machines or any other service, if you are not using it, then you don't need to pay for that. This is the whole philosophy of pay per use or pay as you go. Reliability is very important of a cloud provider system, because high availability is the thing that we expect. It's the expectation of the users who are using this cloud provider system. So reliability actually is about high availability and dependable access to the resource and services. When we say high availability, it will contain different factors, and scalability is one of these factors to have a high available system. Because if we don't have the scalability, then reliability doesn't have any meaning. Because if the service doesn't have the possibility to provide and handle all the requests from the end users, then high availability will be completely canceled. So performance is another issue. The consistent and optimized performance level also is very important for the cloud providers, and often it's backed by the service level agreements or SLAs. So it depends to whom you are providing these services. Most of the times when you are providing service as a B2B contract to other companies, from one company to other companies, they have another document that should be signed, should be agreed on, which is called SLAs or service level agreements. Then we have the security, of course, an undeniable characteristic of the cloud providing system that needs to be a robust security measures, including data encryption, secure access controls, and compliance with the standards. And it's going to be different from one country to another country, one company to another company, one contract model to another contract model. So the service security can be completely flexible in this way. And compliance also, to protect the user data and having control over all of them. For example, having relevant regulation and standards such as GDPR or HIPAA or PCI DSS. So GDPR as a very commonly used regulation for data management and security things, and the compliance things. Portability and interoperability is very important also. It's about ability to move workloads between different cloud environments. So when you have a cloud environment, the whole of the configuration and the adjusting stuff and the deployment resources should be somehow being able to be moved over from one cloud provider to another cloud provider. You shouldn't be stuck to a specific cloud provider. If I'm using AWS, if one day I won't be happy with the services that they provide, I should be able to migrate completely and an easy way to another cloud providing system, or maybe migrate to a private one. So it's something that a cloud provider should support. The portability is very important. Automation also, it's about advanced automation mechanisms and capabilities for the resource management. So everything should happen automatically in a cloud computing environment. There is no excuse for that. There is no reason for the lack of automation in a cloud computing system, because the whole of the cloud is about automation. If you don't support the automation, then the cloud provider is responsible for that. So auto scaling and workflow automation is one of the major things about the automation for a cloud environment system. Disaster recovery and data protection. We need to have specific mechanisms for data backup, disaster recovery, and business continuity. So it means when you subscribe to a cloud providing system, these providers should provide you some disaster recovery mechanism in case of losing any data, in case of any server downtime or anything If you lose the data completely, if the usage of the data will be from the infrastructure level, then the cloud provider is fully responsible for that. And if one day you want to provide cloud as a service, you are responsible. And this is one of the things that you need to think about when you design the whole structure. Managed services like monitoring services, performance tuning, security management, log integrated and central logging system, secret management, and all of those things will be a kind of managed services being provided by cloud computing. So as an example, as I said, Yandex, for example, provides some services related to databases, to file storage system, to containers, IoT systems also as managed services. Even they provide Kubernetes as managed service. They provide lots of other services as managed services. So it means that the service itself is being managed by the cloud provider and you can just use it. Customer support, of course, is very important for professional support services, for troubleshooting, technical assistance, and customer services. One of the things that which is undergoing nowadays, for example, is an AI system being provided by Bosch for a cloud environment system that can work as a customer support system. So this AI system is a model that is being trained by the whole cloud infrastructure. So whenever you have a technical issue, whenever you have a professional support question or anything, you can talk to this AI system. So most of the cloud providers are going toward this approach, and they are preparing the AI models to fulfill this gap. And of course, innovations continuously update and introduce new features and technologies. So let's stick to the scalability as the first important thing. We have two types of scalability. And personally, I say that the scalability are going to happen in two levels: in the software level and in the infrastructure level. Which is something that is happening in my one of my recent researches. So if we want to talk about just the infrastructure level, so we will have vertical scalability and the horizontal scalability. And both the vertical scalability and horizontal scalability should support both scaling up and down. And for the horizontal scalability, we use a different word called scaling out and in. So scaling up means involving and adding more resources or upgrading an existing server. So we have a server, we have the resources, and we want to add more resources, such as more CPUs or more memory or faster disk. For example, we have a server that has, for example, 64 gigabytes memory, and whenever we feel that the server is not capable of providing the responses and the computations, then we add more memories. For example, we make it as 128 gigabytes memory. Then we call this approach scaling up in terms of vertical scalability. And scale down, vice versa, is the reverse process where resources are reduced. So it's about having a server and upgrading an existing server, and we don't want to add more servers. Actually, it's a vertical scalability. And the horizontal scalability on the other side is the time when we have some instances of the servers to a distributed system, for a distributed system, but we actually feel that we need more servers. We don't want to upgrade these server, but additionally, we want to add more servers to this cluster or to this cloud system. So in this way, we say that we scaled it in horizontally, scaled it out horizontally, or scaled it in horizontally. So as you can see in the picture, vertical scaling increase or decrease the capacity of existing services instances. And then at the same time, we have horizontal scaling, which is about adding more resources, like more virtual machines to your cluster, to your system, or spread out the workload across them. So after adding more services, of course, when you add more services and migrate from one server to another server, or from two to three servers, then you need to adjust the replication of your softwares being deployed on these servers, and you need to deploy new versions, new instances of the same software on different on new servers actually. So there is a topic that I wanted to mention because it's kind of scalability in software level, which is a very interesting topic. In Kubernetes, it's HPA, or horizontally pod scalability. It automatically scales the number of pods in deployments, replica sets, stateful sets, or replication control based on the CPU utilization or other select metrics. So it depends on the metric that you select. So you can do these scalability based on the CPU utilization or memory utilization or the disk storage or anything. So metrics monitoring, scaling decision, and scaling actions will happen in such a service called HPA in Kubernetes. So it means, let's imagine you have a Kubernetes cluster that has three nodes or three servers. Then when you have a software being deployed as, for example, one replication pod or two replication pods. So whenever you add a new service, this HPA system is responsible to spread out the new instances of this software on these new servers. Yeah. So elasticity is the degree to which a system can adapt. So it's a kind of measurement of the scalability. The system can adapt to a workload change by provisioning and deprovisioning resources on demand manner. It's exactly about the software level. It means whenever you scale the infrastructure, how your system is able to elastic these services running on these different resources. So how system can adapt itself to the new changes. So AWS Elastic Compute Cloud, or EC2, allows for automatic scaling of instances. It means that it's an elastic system. Azure Autoscale enables you to automatically scale compute resources on Microsoft Azure, or Google Compute Engine provides auto scaling that helps your application actually to handle the increases in terms of traffic, in terms of requests, in terms of computation, and all of those things. And it reduces the cost when the need for resources is lower. It means that it supports the scaling down, automatic scaling down. It means whenever you have a lower need on this resource, then the cloud computing engine is responsible to scale down the system to avoid any money wasting or something like that. So the next up is about on-demand self-service, allows users to automatically provision computer resources. So the factors on that is the user independence. It means that you shouldn't be dependent on any specific user or operator. So it should be completely user independence, instant provisioning. It should happen at the right time, and quickly. Automation, it should be automated, it should have enough flexibility, and it should provide you the control and the monitoring. These are the factors for on-demand self-services. So whenever you want to use a service that provides on-demand self-services, the major topics that you need to investigate and understand and analyze and make decision if it's the relevant service to choose for your needs or not. These are the factors that you need to pay attention to that. As an example, compute resources, for example, EC2, Google Compute Engine, Microsoft Azure. Storage services will be Amazon S3 or Azure Blob Storage, which are providing services for S3 bucket or object storage systems. networking, for example, Amazon VPS, we have a service called VPS in Amazon, which is responsible fully for the networking stuff. Amazon Road 53 is a DNS service that's being provided by Amazon, that you can create your own local DNS system and your own way of domain name translation, actually. Elastic load balancing, or ELB, AWS Transit Gateway. It's an API gateway that you can use for your microservice architecture stuff. Amazon CloudFront, which is a CDN that works quite well for edge computing and specifically for IoT stuff, for media streaming, for media caching thing, and live streaming. So CloudFront is fully about CDNs. Amazon Security Group, or firewalls, which is a system that acts exactly like a firewall. You can manage different accesses to your network, and different ports opening, closing, or restriction of the networks. So databases, for example, Amazon RDS or Google Cloud SQL are some examples of the elastic services being provided by these cloud providers. So until here, is there any question? If you have any question or concern, you can just open your mic and ask me. Is there anyone who has any question?
Could you clarify a bit more the difference between horizontal and vertical scaling?
Yeah, exactly. So as we said, vertical scalability is the time when, so let's imagine you have a server, and this server has a specific amount of CPU cores, specific amount of memory, and specific amount of storage, disk storage. And the number of your users will suddenly go high. And the server that you have is not capable to handle all of those requests. And you make a decision somehow to scale it. It means to provide more resources, to add more CPU cores, or to add more memory, or to add more storage. In this way, when you upgrade and make an existing server more powerful, then we call it vertical scaling. It means that vertical, you scale it up, you grow it. At the same time, when you don't want to touch the current specification of your server, but at the same time you want to have more capabilities and more powers on your system. So most of the times in cloud environment, we provide servers as a cluster of nodes, or each node is going to be physical server, or it can be a virtual machine, or it can be any kind of computing unit. So you have a cluster that has one node, for example, and you see that its one node is not capable to handle all the operations. Then you add another node with, either it can be the same specification or with a different specification. So it means that you horizontally scaled it. It means you added new servers, new nodes to this cluster, and then you add another one that can be a 3 node or 4 nodes or 5 nodes, but you don't touch the specification of this specific node. It means that we are horizontally scaling the cluster or the cloud system. So does it answer your question?
Yeah, thank you very much.
Great. So if there is no other question, let's jump to the broad network access, which is one of the major complexity and the difficulties of creating a cloud computing system, and actually the money consuming high expenses for these broad network access. If you want to provide a cloud system that can provide services to the whole of the world, then it should designate to support heterogeneous client platforms, different type of client platforms. It ensures that user can consistently access cloud services without any problem with the access, because if something happens with the access, then lots of services will get impact, lots of money will be lost, and lots of damages would happen because we don't know what kind of services are running on these cloud infrastructure. For example, for Amazon, Netflix infrastructure is fully available on Amazon. And if something happens with the network access of Amazon, then the whole of the damage and the whole of the money losing will be for Netflix. And then what Netflix can do with it. So it's one of the major topics in the contract that they have with AWS, and that the AWS should ensure, and they should be completely confident about the network access, broad network access. Let's imagine you are watching a movie, and in the middle of the movie, it just stops. And it's not the fault of the Netflix, it's the fault of the cloud network provider with the networking stuff. So they should consistently have access to the cloud services regardless of their location or the device they are using, provided they have an internet connection. So the whole idea behind the cloud computing is that we shouldn't be worried and we shouldn't be dependent on the device and the location. The whole thing which is required to have access to all of these cloud computing systems, it's just a simple network connection. Whenever you have a network connection, then you should be able to use the whole technology behind cloud computing. This is the whole idea about that. And global infrastructure, there should be a global infrastructure. It means we cannot have just a bunch of servers in United States and connect the whole people from all over the world to this data center or to this network, because it's not possible. We have the geographical limitations, we have different network speeds, and all of those things. So sorry, very urgent meeting happened. So yeah, I try to be fast. So about regions, we should have our data centers in different regions. We need to divide our network accessibility into different regions because so we need to have availability zones actually. So Amazon, for example, had different availability zones. Number of them are in Europe, in Asia, in the United States, in Australia, and all of those places, because we need to have edge locations. We need to have as fast as possible access to the cloud services. So yeah, Professor, I don't know how much time we have, but as we mentioned in the summary of the text that I sent you, we can have different sessions also for that, because we have a lot of things that are remained, and I don't think so that in this session it will be ready.
Yeah, I think you have quite a lot of material rest, so we may split this lecture and postpone the second part to the next week, because this lecture, this part you already told is was quite intensive. I think it quite enough today.
Yeah,
maybe now some time for questions and answer, and we will wrap up maybe.
Yeah, of course. So if there is any question, I'm happy to answer. Yeah. So any concern, anything to talk about?
What do you think? What are the weak point, weak places of clouds? What are the disadvantages?
Disadvantages
When
nowadays.
yeah,
Mhm. Yeah, I think nowadays with the improvement of the AI systems and the complexity of different technologies and the softwares, it's still very complicated for the companies to migrate because they don't have enough enough expertise in this area. So the difficulty and the whole complexity in terms of engineering of a cloud environment is very hard still, and we still need to have people working with it. Lots of people in different sections of this cloud computing system. I think one of the very hot topics nowadays, which is going on now, and it will be much more important in the future, is the combination of AI systems, especially generative AI systems with these cloud infrastructures. Because whenever you get stuck in one of these cloud environments, then there is no one to help you, and talking just to support is not sufficient, and you need to have and get more knowledge every day for these infrastructures, and they provide update every day, the new deployments, new strategies. Then you need to continuously learn and update yourself. But I think a combination of the AI system that comes to the scene and help the humanity in cloud computing is a very major thing that should happen as soon as possible, because if not, the number of services, the number of the amount of complexity is getting higher and higher every day, and the human being manually is not able to manage all of those things. So I think lack of combination, well-defined communication between AI systems with the cloud computing is the major weakness of the cloud computing system nowadays. Yeah. So did it answer the question? Or
yes, thank you, thank you.
So I'm ready to answer to any question even after the lecture. You can have my email. You can talk to me. You can reach out to me if someone is interested in a specific uh, section in cloud computing, a specific topic. We can have discussions. We can talk, and I will be very happy to share any knowledge that I can. So that is all from my side for today. Good luck to everyone. Next session, I think Professor you will manage it somehow. So just let me know any convenient time. Then I will be happy to continue with the lecture, because the rest of the lecture is very interesting. It's more technical stuff. It's more about the networking stuff. So I think that would be very helpful also.